Hello, today we're going to be looking at random sampling and probability. Before the 2005 season, MLB instituted a new policy which included more testing and more severe punishments for players caught using performance-enhancing drugs. So the gist is that we want to make sure that the tests are conducted randomly so that people won't know when they're going to be tested. So that they can't take steps to avoid the detection. The issue is that testing all the players in the MLB would be very time consuming. And so what we want to do is maybe have the league take a sample and generalize their results to the population. So we're going to define some words, lots of definitions today. So a population, when we talk about a population is the collection of individuals that you want to know about. Like the entire collection of individuals you want to know about. That means everyone. Okay? Everyone is the population. So the population of Plymouth High School would be every single student that goes to Plymouth High School. Every single one. Even absent students would have to be included in that population. Okay? Now, a sample is a subset of the population that is chosen for study. So, for example, and this is how sampling works. If 18% of players sampled tested positive, then MLB could infer that approximately 18% of the entire MLB population would test positive as well. Okay. So what happens is that we do something to a sample and we can infer that to the entire population. So we're allowed to do that. A generalization from sample to population can be made as long as every player, in this case, every player in Major League Baseball, has the same chance to be selected as part of the sample. So there's no reason for players that take performance-enhancing drugs to be more likely selected, or players that don't take them are more likely selected. Every player has the same chance of being selected. Now, when every possible sample of the desired size has the same chance to be chosen, that is called a simple random sample. So a simple random sample is when everybody has the same chance of being selected. So you would put the name of all the players in a hat and draw out the desired number of players as a sample. Okay. I'm going to skip to here for right now. Even though this simple random sample seems to be the preferred way of sampling, some people might have an issue with that because it wouldn't guarantee that every team was represented. So let's say that you wanted to divide it into teams, like have a hat for each team, and then take a couple players from each of the teams. When a sample is chosen by dividing the population into groups and then taking a separate random sample, that is called a stratified random sample. So a stratified random sample basically means that first you divide into groups. So you divide into groups first, then you choose. Then it's random after that. So the nice thing about a stratified random sample is that it guarantees that each subgroup is represented. So that might be something like if you wanted to make sure that, like if the PSEP was doing a survey and you wanted to make sure that every grade was represented, you could say, all right, I'm going to take 10 freshmen, 10 sophomores, 10 juniors, and 10 seniors and sample that way. So these are different sampling methods. An alternative method, we'll back up here, to generalizing results from a sample to population is surveying every member of a population. So that is called a census. So like when the US has a census, they want information from every single person. And like technically, statistically, a census is that every member of the population, everybody. So like that would mean that if I wanted a census of the class, that means that everyone would have to show up. So that means that a census can be very difficult to conduct because you need results from everybody. Okay, so those are some vocabulary words. So let's take a look at how we would be asked questions using some of these words. So example 1 says, magazines such as Sports Illustrated regularly survey professional athletes about a variety of subjects. Let's suppose a magazine randomly selected 90 of the 360 NBA players who were on the team's opening day roster for a survey about officiating. Let's describe the sample and population in context. So the sample in this case would be who's randomly selected. So this would be the 90 players randomly selected. So do two things when you describe the sample. Give the number, and then how they were chosen. And they said here that they were randomly selected. So, I mean, it could have been the 90 oldest players. The sample may have been the 90 players who were oldest, or the 90 newest players. But that's not what they did. It was the 90 players randomly selected to take the survey. So it is important for you to discuss not just how many are in the sample, but how the sample was obtained. And here they're saying that they're randomly selected. And then it also asks about the population. So the population member is the entire collection of individuals that you want to know about. So the population would be all of the players. So all 360 NBA players. And what type of NBA players were these? They were NBA players on the opening day roster. That's very specific, rather than saying just 360 players or 360 NBA players. These were 360 NBA players on the opening day roster. That was our population that we were concerned about. Okay? Then it says, explain why is it important to randomly select the athletes for the survey. And this is one that has the same answer every time. The reason that we randomly select is to ensure that every athlete, in this case, they're all athletes, has an equally likely chance of getting chosen. Or you could say being represented for something like this. But they have an equally likely chance of getting chosen. So this idea, the equally likely chance of getting chosen, is always basically our answer to why it is important to randomly select. So why do we randomly select? To ensure that everybody has an equally likely chance of getting chosen. Now letter C says, why do you think the magazine used a sample rather than conducting a census? And we mentioned before that a census would be difficult. So a census, again, would be difficult to implement. And let's talk about why. First of all, it would be difficult so it would be hard to contact all 360 players. First of all, that would take time. Secondly, if they're doing that, if it takes more time and they're paying writers to do that, that's going to cost money. So it often takes a lot of extra time and money to conduct a census. So that's probably why they used a sample instead. And so now let's discuss how many different samples of size 90 the magazine could use. Well, they have 360 players and we're choosing 90. Does the order that they're being selected matter? It doesn't. So that's going to be a combination. And so we're going to think back to the last lesson where we used combinations. There were 360 total, and we just want groups of 90. So we would take 360 C90 and let's see what we get. So here's 360 C90, and here we get this E thing again. Remember that E represents scientific notation. So maybe we'll just round to maybe 3 decimal places here, even though it's not really a decimal, because remember that E86 means that we're moving this decimal place over 86 times. But we'll say that this is about 4.024 and then times 10 to the 86th power. Okay? All right, so example 2, next page. Based on the definitions that we've talked about, let's decide if each of the following scenarios represent a simple random sample or a stratified random sample. And then we'll find the number of different samples that could be taken. So letter A says, a professor numbers his students from 1 to 200 and randomly selects 40 of them. Well, in this one, he's just numbering students from 1 to 200, selecting 40 of them. It seems like everyone has an equally likely chance of getting chosen. They're not being divided into subgroups at all. So because everyone has the same chance of getting chosen, this is considered a simple random sample. And as far as the number of samples that could be taken, well, he has a total of 200 students, and we're picking a group of 40 of them. So we would want to find 200 C40. And that's going to be about 2.050 times 10 to the 42nd power. Okay, so that's example 2A. 2B. From a group of 100 employees, the manager randomly selects 12 of the 60 women and 8 of the 40 men to form a sample of size 20. So does everyone have the same chance of getting selected? Well, it looks here like we're dividing it into groups first. They divided it into women and men. So because we divided it into subgroups, this is a stratified random sample. So again, stratified is when it's in groups first. So let's look at one of the groups. The first group that they had was women. There were 60 total women, and they were selecting 12. So that would be 60 C12, because the order doesn't matter. There's also a subgroup of men. There were 40 men, and there were 8 being chosen, so 40 C8. Then we would multiply those different ones together based on the fundamental counting principle. And you can enter that in your calculator all at once. You can just say 60 C12 times 40 C8, and that gives us about 1.067 times 10 to the 20th. Oh my gosh, 1.076 times 10 to the 20th. Okay? So that's the difference between simple, stratified, random sample. So that's the first part of today's lesson, the idea of random sampling. So again, a lot of different vocabulary here. Make sure in your homework, please practice, like we did in class, being very specific, okay? The second part of today's lesson is about probability, which I know that you guys have discussed before. And we know basically that probability is the number of desired outcomes over the number of total possible outcomes. The number of total possible outcomes is often called the sample space. So if you hear the word sample space, that's just looking at everything that's possible. And hopefully in what you've done with probability before, you know that the probability is always between 0 and 1. And the probability indicates the likelihood that an event will occur. And so if we interpret probability, in this case, we're going to be talking about like picking things over and over. And so we'll practice interpreting this. But basically, if something were to be done over and over and over again, then we would be successful a certain percentage of the time. So we'll practice that in example 3. So example 3 says a coach has 12 players on a basketball team, which includes 5 guards and 7 forward centers. To avoid an unbalanced lineup, the coach wants to choose 2 guards and 3 forward centers for her starting lineup. So what is the probability that out of all the lineups the coach could select, the coach selects a lineup with 2 guards and 3 forward centers? So I always have to write this stuff out. So I'm going to say, all right, what do I want here? She wants 2 guards and 3 forward centers. That's her desire. That's what she wants to get. That's the lineup she wants. But the sample space, the total possible outcomes, would be basically choosing any 5 people for her lineup. And I think thinking about what we're looking for will really help us put the numbers into action. So let's talk about getting 2 guards. How many guards are there to choose from? Well, this says there are 5. So there are 5 guards to choose from, and we want 2. Does the order that she selects the guards matter? No, so that's a combination. We also want 3 forward centers. How many forward centers are there total? Well, there are 7 forward centers total, and she wants to pick 3. Again, order doesn't matter, so I chose the combination. Fundamental counting principle says that we would multiply those possibilities together. That's going to be my numerator. The denominator is any 5. So all together, the whole sample space, how many players are there to choose from? There are 12. And in this case, we want to choose 5. And again, the order doesn't matter. So essentially, this is what we're going to have. We're going to have 5C2 times 7C3. That gives us 350. Oh, sorry. 5C2 times 7C3 is 350. We're also going to have 12C5, which is 792. So that means that we're going to have 350 over 792, and then we can divide. And we usually round probability to 3 decimal places. So that 9 is going to bump that 1 up to a 2. So that's going to be about 0.442. Okay. As a percent, that's about 44.2%. So either of those is acceptable to have the answer. So let's interpret the probability. When we interpret the probability, the general context is usually what we're talking about in our denominator. And then the description of the desired context, this is really our numerator. So we have our denominator. So if our denominator were randomly selected repeatedly, we'd get our numerator about what percent of the time. And that's what we do here. So our denominator was picking 5 players. So we'd say if 5 players were randomly selected repeatedly, or over and over and over, or if we were to select 5 players over and over again, so basically you're just talking about selecting, like looking at this sample space over and over, then we would get what we want. And again, we wanted 2 guards and 3 forward centers. So 2 guards and 3 forward centers. Oops, I can't spell. Would be chosen. So that's kind of what we're doing here, talking about what our desired context is. So we would want 2 guards and 3 forward centers would be chosen about 44.2% of the time. And so that's how we could interpret that probability. If any 5 were chosen, so if 5 players were chosen, then 2 guards and 3 forward centers would be chosen about 44.2% of the time. Do not use the word probability to interpret probability. If you said there's a probability that this would happen, no. It's just you talk about the likelihood of the event, but don't use probability to interpret probability. All right? All right, we'll do another one like that in the your turn on the bottom. But here's one that's slightly different. This one says the Chiefette Show variety is allow students to showcase their talents every fall. For the Friday show, they have 10 acts scheduled to perform. The order in which the acts perform is randomly selected during the show. 2 of your friends are singers in different acts and are part of 10 acts. What is the probability that the first 2 performers are your friends? So let's look at what we want. We want the first 2 performers to be friends. So we want the first 2 to be our friends. Now when we talk about the sample space here, we're really just focusing on the first 2 performers. We don't care about the last 2 or the middle 2. We're just focusing on the first 2. So our sample space would be that the first 2 could be anyone. So we want the first 2 to be our friends, but our sample space would be anybody being the first 2. So let's think about the first 2 being the friends. And again, we don't care who goes first or second. We just want that group to be considered. So how many friends do we have? We have 2 friends that are in the show. And we're looking at the first 2 acts, so there would be 2 people that were there. So we would have 2, 2. And again, the order doesn't matter. I know that it says that the order is being randomly selected here, but we don't care in this case who is going first or second. We're really focusing on that group of 2, the group of first 2. All right? So we have 2 friends, 2 performers in the first 2, 2C2. Well, now let's look at anybody. It says that 10 acts were scheduled to perform. So that means that there are 10 acts total. And again, we don't care about the order. We're just looking at what the clump of the first 2 would be. So we would take 2C2 over 10C2. Well, I know 2C2 is 1. And then 10C2 is going to be 45. So if I take 1 divided by 45, you can see that I get about 0.022. So I get 0.022. Again, if you like percents better, that's about 2.2%. So the probability here, if we were to interpret it, would be if any first two acts are chosen. So we can say if the first two acts are randomly selected repeatedly, what we wanted was our two friends, okay? So my two friends would be chosen. That's what we wanted. Only about 2.2% of the time. So that's how you could interpret that probability. If the first two acts are being randomly selected, then my two friends would be chosen for those first two acts only about 2.2% of the time. Okay? Remember, if you need to back up, this will be online and you can rewatch whatever you need to. So let's approach the U-turn together. This one is more similar to example 3. And these are the ones that show up on the test and the final exam. I said that out loud. Okay. Indiana University has 18 females and 11 males trying out for their cheerleading team. The final team will be composed of 12 members. Find the probability that 6 females and 6 males will be on the team, and then interpret our answer. So let's first think about what we want. We want 6 females and 6 males to be on the team. So 6 females and 6 males is what we want. The sample space would be any 12 people chosen. And so now let's put the numerical values in. So we want 6 females. How many females were there total? 18. So we'd have 18C6 times, and then we have 6 males that we want. There were 11 males total, so that would be 11C6, and that would be our desired. Now we have any 12. So we want to choose 12, but how many did we have to choose from? Well, 18 plus 11 is 29, so we have 29 total, and the whole team will have 12. And to be honest, if we have that, we can just take 18 C6 times 11 C6, because these numbers get kind of big, and then divide by 29 C12, and we can see that's about 0.165. So you could find the numerator and denominator individually if you wanted, but so this is 0.165 or 16.5%. So our interpretation would be then if, let's see, we're picking 12. So if teams of 12 were randomly selected repeatedly, what we wanted was 6 females and 6 males to be chosen. So 6 females and 6 males would be chosen. About 16.5% of the time. Okay, so hopefully that makes sense to you, and now you guys can start the homework worksheet. Again, if you need to rewatch anything, it's online, and we'll discuss this more when I get back. All right, you guys have a good day.